Hello, my name is Richard Bond and I'm the Innovation and Engagement Director for the Coal Authority. And I'd like to thank you for joining us at this webinar today. We hope that you'll find this an interesting introduction to what we're doing with partners to facilitate clean energy from the coalfields as we develop the exciting potential of mine water heat in the session today. But just a diary date for the future, on the 16th and 17th of March, we are going to be holding the 2022 Mine Water Energy Symposium in partnership with IEA Geothermal, the British Geological Survey and BEIS. And that's going to provide a greater opportunity to explore in detail some of the more technical items. And we'll be giving you details for that session later in the presentation. We also wanted to take this opportunity this morning to provide an insight into the general work of the Coal Authority. Could I have the next slide, please? The Coal Authority are a UK government non-departmental public body, sponsored by the Department for Bays, Energy and Industrial Strategy, that's BEIS, and we work across England, Scotland and Wales. The Coal Authority was established in 1997 following the 1994 Coal Industry Act. And we have a mission to make a better future for people and the environment in mining areas. We own, on behalf of the UK government, the majority of Great Britain's coal mine workings and mine entries. And we also hold all coal mining records dating back to 1792. And the digitised database of this helps us in all aspects of our work. Safety and protection runs throughout our purpose, which is why we're a 24/7 emergency response body. As such, we are predominantly a mining remediation authority, supporting people impacted by mining subsidence, treating polluted mine water to protect drinking water and the environment, and working with the conveyancing market, developers, and infrastructure providers to help them make informed decisions when working on the coalfield. Next slide, please. To give you an understanding of the scale of our operation, we're responsible for managing £2.4 billion worth of coal legacy liabilities in the form of the UK's coal resource and abandoned coal mine workings. Our responsibilities include public safety and subsidence, ensuring the public are kept safe from coal mining hazards and remediating any damage caused to properties from subsidence. And you can see on this slide images on the top of a shaft collapse in northeast England and our remediation of this hazard, leaving residents safe and intact in their properties at the end. We also have responsibilities for environmental protection, managing mine water discharges and their impact on the environment. We have over 800 mine watering monitoring points and 76 mine water treatment schemes that prevent over 4,500 tonnes of iron solids entering our watercourses. The lower images on this screen you can see show the impact of treatment on a watercourse in South Wales. And you can see in the middle actually what one of our mine water treatment schemes or a section of it looks like. We also have responsibility for providing information to the public, advising the public, partners and other key stakeholders about the coal mining legacy under their feet through property reports, advisory services and events such as this and wider media engagement. Next slide, please. We're a small organisation, but we have a big remit. And what you can see on the screen in front of you are some of the highlights of our work in the year 2020-21. Each year, we carry out a rolling programme of several thousand mine inspections. And last year, we assessed just over 200 subsidence damage claims. We helped sustain the housing market on the former coalfields by delivering over 195,000 mining reports. And those mining reports are a vital part of the search that surveyors undertake on properties in coal mining areas. And we provided over 7,500 planning consultation responses. Our environmental activity included treating over 122 billion litres of water by removing iron ochre, which is a byproduct of mine water, and saving £2.4 million by recycling the rebed material that we use in our mine water treatment schemes. Our focus on value creation ensures not only that we minimise our cost to the taxpayer, but that we develop opportunities such as mine water heat to deliver future environmental benefit from our mining past. Next slide, please. We recognise our past shapes our future, and at the Coal Authority, we've increasingly been focusing on the low carbon opportunities from our former nationalised coal mines, and not just the legacy risks. In recent years, we've begun sharing our knowledge about disused coal mines as a potential source and store of low carbon heat. We estimate that 25% of homes across Great Britain and 9 out of 10 of our biggest cities, that's all except London, are on the coalfields, creating a good overlap between heat demand and potential mine water heat resource. BASE's heat and building strategy recognise the complexity and range of options that are likely to be needed to address what we need for heating, and heating currently uses about 40% of domestic energy use. Minimising the heat impact on the electricity grid would help leave capacity for electric cars and other key transformations. And heat networks are going to be a key part of providing this answer. Working with the British Geological Survey, we've developed interactive maps which show the potential of mine temperatures across Great Britain and can be used as initial planning tools to help partners such as local authorities, developers, businesses, and the horticultural sector to plan investment. The Coal Authority are working with a number of partners to review the potential for the adoption of mine water heat. And we've already got 2 schemes in development at Gateshead and at Seaham that will provide heat for homes and businesses. And we'll be providing some more detail on these exciting projects during the course of the webinar. At the Coal Authority, we believe it's important we make our webinars accessible for all, and as such, provide our webinars with transcripts. Everyone who has joined us today will receive a link of our webinar in the next 7 days. If you require a transcript or a subtitle version of today's webinar, please send your request via email to minewaterheat@coal.gov.uk, and these will be available early next week. We hope you find our presentation this morning of great interest, and thank you for listening and for being here today. I'll now hand you over to Gareth Farr, our Head of Heat and Byproduct Innovation.
Thank you very much, Richard, and thank you to all the attendees for turning up at lunchtime to hear about clean energy from the coalfields. My name's Gareth Farr. I'm the Head of Heat and Byproduct Innovation at the Coal Authority. So let's start at the bottom with a slide on coal. I'm assuming most of you have a good background, but if not, coal can occur across various ranks or types, all the way from lignite, which is pictured at the top, quite a soft, dark brown coal, all the way over to the really hard anthracite deposits that we get. And you can see on the slide on the right-hand side, different properties of the coal will vary throughout their ranks or types. Coal obviously has had multiple uses, from heating, industrial processes, and steam and power generation, and so on. So coal production or extraction across Great Britain has of course occurred underground, where coal seams have been worked using various methods for several hundred years. And the coal mining using this approach does create an anthropogenically enlarged aquifer ultimately to hold water. Coal can also be extracted used from open cast sites, and the one you can see pictured here is Blindwells, pictured in 1982 in East Lothian in Scotland, which is another method of extracting coal where the overburden is removed and the coal is directly removed from the seams. Overall, there's records of at least 23,000 collieries in Great Britain that have operated at one time or another. And the official stats are that 25,000 million tonnes of coal were removed between 1853 and 2020. At the peak of the coal industry, nearly 1 million people were employed, but as probably the majority of us know now, most of the coal mines are now closed, so we're left with a large infrastructure below ground. So subsequent to closing of the coal mines, many of the underground coal mines were pumped to keep them dry so the miners could extract the coal. As the pumps were turned off and the mines were abandoned, so a process called mine water recovery occurred in some coal mines, whereby they become filled with water from the surrounding aquifer. And once the mine water reaches the sort of the natural points of the surface, it can require management. And on the right is one of our many mine water treatment schemes. This is Saltburn Gill, and it's where we take mine water and either actively or passively treat it. So yeah, and like I said, we've got 76 mine water treatment schemes, and every year we treat 122 million meters cubed of water, preventing 4,500 tons of iron solids entering watercourses. So really the question is, how can we reuse or repurpose this industrial legacy to provide hopefully a low carbon geoenergy asset for the future? So first things first, hopefully we can access the mine water and use it to create heat. So firstly, once we've got underground, we might ask ourselves, well, how hot is the mine water? In short, we've did some work with the British Geological Survey, and on the right hand side is a little snippet of data from the South Wales coalfield. And what you can see is that temperatures can sort of be variable even within coalfields, but they are certainly variable across Great Britain. And other things such as pumping and complex hydrogeological settings can add to the variability. But on average, a geothermal gradient of about 24 degrees per kilometre can be applied across Great Britain, but you can see below the range can extend beyond that. And in short, the simple rule is that the deeper you go, generally, the warmer the mine water becomes. And below a certain depth, you would hope that the seasonal variation in temperature is minimized. And of course, that's important if we're using it as a source of heat. If you'd like to read more about that or view the maps that Richard mentioned before, or that this data is contained with, there's open access papers, and also our Coal Authority viewer will enable you to see the map outputs. So how do we physically access mine water heat? Well, broadly speaking, we can have three broad options. The first one is you could utilize an existing site, such as a mine water treatment scheme, where mine water is brought to the surface naturally. And I'll talk about an example of where we hope to do this in the near future. Another possibility is that we can use existing mine entries to access mine water to recover heat. However, you're sort of driven by where these occur, and of course many of these were made safe and backfilled and capped, so that's how those lie. Probably the most common way so far of doing it is to drill bespoke boreholes at your site of interest to access the mine water. And again, I'll give an example of a site where we're doing such a thing. So here's our first example, and this is what we term a bolt-on scheme. So in this little infographic, we are showing something that is similar to our Dordon mine water treatment scheme in the northeast of England. There's a mine shaft. The mine shaft's 400 meters deep in reality, and the pump sits at about 100 meters. This diagram's slightly compressed for ease of viewing. And the water is abstracted about 80 litres a second on average at 20 degrees. And currently that gets treated through the mine water treatment scheme, and once it's clean, it gets discharged to the coast. However, the plans are on foot, and we've been working with Durham County Council to facilitate recovery of this heat from mine water, from the Dordon mine water treatment scheme, to supply a development called Seaham Garden Village, and that's what's represented here on the right. So generally how it works from the base up is that the mine water will be abstracted and the heat will be removed from said mine water before the mine water then carries on and gets treated and goes to the sea. Then a clean loop of water, that's the important one, will be sent around the homes and the radiators to transfer the recovered heat and create space heating and hot water for the homes on site. And so that one's being led by Durham County Council. It will include 1,500 homes, a primary school, shops, and also hopefully an innovation centre. It's also expected to save 2,250 tonnes of CO2 a year once constructed. So to give you a glimmer of what the Seaham Garden Village will look like, and I was there 2 days ago and it was glorious in the sunshine, so it would be a lovely place to live, is such here. So in the top right hand corner in the red circle is where our mine water treatment scheme is, and the sort of blue line represents where the sort of heat network may go around the new development. So it's really exciting times, so watch this space on this development. So our next scenario is the bespoke borehole drilling scheme, and hopefully I'll play a little video now and aim to talk over it. So when we drill boreholes, we'll generally target a deeper, warmer working, and the water will be removed with heat removed from a heat exchanger, typically 5 degrees. Then that water is returned to another set of workings. And then as you can see here, we've got a heat pump to boost the temperature, and then the clean loop of fluid is circulated around the homes or through the heat network to provide heat and hot water. So this example, this is a sort of very generic graphic to explain it. So in reality, we are actually facilitating, or well, we're supporting and providing advisory services to Gateshead Energy Company, which is associated with Gateshead Council. So the northeast really is really currently the home of mine water heating. There's several exciting projects and existing schemes operational up there. This is one we've been closely involved with. A council-owned energy company ultimately will run it. And it uses 2 abstraction boreholes of about 150 meters depth, which target fully flooded hut and seam workings. That water is abstracted from said workings, the heat taken off, and it will run through a heat network. And I think about 3 megawatts of heat's coming off, and it will be coupled with existing CHP plant and heat network that's also in Gateshead. And the plan for this one is to provide heat to about 1,250 homes, Gateshead International Stadium, and other council-owned buildings in the area. And again, this one probably should be saving around 1,800 tonnes of CO2 per year. And the pictures here just show a borehole being drilled. I think this might have been the abstraction well, so 150 meters-ish deep into the hut and workings. So like I mentioned and Richard mentioned, the Coal Authority do work with multiple partners, a lot in the northeast, because this is where a lot of work is happening, but also across England, Wales and Scotland. We're very happy to have support from BEIS, but also we work closely with the Northeast LEP, multiple academic institutions, and we have close working relationships with environmental regulators, who of course have a regulatory duty to assess these sites as well. We also work with governments in Scotland and Wales and the Mine Energy Task Force. One of the key organisations or types of people we work with are local authorities, but we can also work with energy and commercial companies to help support these schemes. So funding sometimes is something that is clearly an issue when you're taking on a project that has high capital costs at the beginning, but various schemes we've mentioned and others in existence, if they haven't had private funding, they have also gone to triple point heat. There's Heat Networks Investment Programme. Green Heat Network Fund is a good one coming out, and I've seen actually there's a webinar coming up soon to tell people how they can apply for this fund. There's also the HNDU, Heat Network Delivery Unit, has been instrumental in underpinning decisions for these and so on. And a colleague in Scottish Government also brought my attention to the Heat Network Fund for Scotland, which totals 300 million and could also be a suitable source of funding should you wish to consider one of these schemes in Scotland. So let's talk about some mine water heat opportunities. As Richard mentioned, there's a good synergy between where people live and where mine workings occur. And this slide on the right here is produced by Bays and ourselves. So the bright colours, the purples and the reds and the whites, represent annual heat demand density. And the sort of white outlined areas show the sort of extents of the coalfield areas in Great Britain. And you can see just by eyeballing it, apart from the majority of the southeast, other than, of course, the small Kent coalfields, apart from the majority of the southeast, a lot of the rest of the country has a good synergy with populations and coalfield extent. In this talk, we've mainly given examples for where heat will be recovered, but also we do consider cooling will also become a current or future need in greater quantities, and these schemes can be run to provide cooling. And perhaps in the near future, we may also be able to use the large volume of water that's held within some of these mine workings as interseasonal storage for heat. So if we think like large geo batteries potentially. Some benefits, some clear obvious benefits of mine water heat is that it's located in our own country, and there's no time like the present really to consider the importance of energy security. But coupled with that, we hope it also delivers green jobs, carbon reductions, and also ultimately a reduction in fuel poverty. So another take home for people that aren't too aware of the subject is that although this may sound like blue sky thinking or very novel technology, the first mine water heating scheme I could put my finger on came from the United States in 1979. And since then, the UK has implemented several small pilot schemes and small operational schemes, but we're just at the stage now where we're upgrading or upscaling to heat networks. If you've got the pleasure of going to the Netherlands, to Herleen, there's an amazing scheme there, as in the north of Spain and also in Germany. So the take home is that really the technology and approaches have been proved at scale in other countries, and it's certainly something we believe is applicable to Great Britain and can be upscaled as well. So let's say we have an area we're interested, how would we go around actually considering whether it's suitable for mine water heating projects? Well, the first stage really would be a high-level site assessment. The Coal Authority viewer does have open access information on it, but also you can drop us a line and we can give you an initial high-level assessment of whether we think you should progress further in a given area. We'd generally consider, a high-level review of mine workings, mine water state, because not all mine workings are fully flooded and not all are fully recovered. There can also be other issues such as gas and so on. We can also provide indicative areas for drilling, outline costs, any other risk and mitigations, and next steps. So if your next step says, yes, actually, I think you should proceed with this area, it looks promising, we can roll on to stage 2, which was you can get a finer level of detail. I mean, the Coal Authority are custodians of all the mine closure plans, and here you can see a very detailed plan. And this is the type of abandonment plan we'd use to target suitable drilling locations. And these are available to ourselves, but also available to all of you as well, under the same T's and C's. So we use these to identify potential target workings, look at the accuracy, because different plans have different accuracy. We also look at sort of recirculation risks, because of course the mine water needs to come out of a mine, and in most cases it will need to be returned to the same mining area or mine block. And we'll then be able to help sort of increase detailed cost analysis and consider permitting and licensing requirements. A drilling site. The next stages for any project are to consider permitting and licensing, and broadly you need to get permission from ourselves to enter mine workings and work towards a heat access agreement, but also at the same time it's likely you'll need to speak to your environmental regulator, whether that be Natural Resources Wales, Environment Agency or SEPA, because they also need to provide abstraction licenses and permit to recharge water. But we have the framework to take you through these things, and a lot of these processes are similar to any other activities under Water Resources Act or similar. Also can provide outline design of boreholes and technical input then to tender for drilling, so actual technical specification for what your boreholes should look like. So once we pass the preparation stage, and we'll be glad to know the paperwork should be going, we can get onto the fun stuff now, which is safely constructing the pilot and production wells. This image is of some work actually on the Gateshead scheme here, and you can see the backdrop of Gateshead there in the distance. So, you know, we can support the general approach would generally be to look at pilot borehole drilling first to prove that you can hit your target. And then production borehole drilling, and these boreholes tend to be larger to accommodate pumps and also a greater flow of water and return of water. There's also multiple things we do to make sure that drilling into coalfields is safe, and I won't go into detail here, but those are all covered in all of the applications. And once your boreholes are in position, then your next task really is to consider how well you can abstract water from any given workings and how well you can return it to any other workings. And this is what we call a pumping test. So for the hydrogeologists out there, this will be day-to-day work for you, but these are the tests that we use to quantify the capacity of given workings to provide a specific amount of water at any given time. And these are really vital numbers to allow the design of the system to assess its capability, but also to enable it to be sustainably operated. And once these tests have been undertaken, then hopefully all the various licenses from regulators and both ourselves can be completed, and you find yourself with everything in place to continue installing your heat network. So to conclude, the mine water heat resources in Great Britain do align with significant urban areas, and thus there's an obvious synergy between hopefully demand and resource. Although there's many pilot schemes and some privately installed schemes, the first heat network due to go to multiple homes and businesses at scale really is due to be realised in Gateshead in 2022. We believe mine water can provide a low carbon solution to heating and create green jobs and also improve energy security. And the Coal Authority can provide advice and support from initial feasibility stage to completion of your project. And I'd just like to thank you all for taking your time to listen to this, and for those of you that are technically minded and are craving more detail, I'm very happy to say there's a free conference over 2 mornings with speakers from across the world. So if you use the Mine Water Energy hashtag on Twitter or LinkedIn, it should take you up to the sign up page for this, and it really will be 2 fascinating mornings, and I hope to see you